Hi everyone. Today we are going to be talking about solving quadratic equations by factoring. We are going to be looking at two word problems. Go ahead, grab a piece of paper and a pencil, and let's get started. The first question we're going to look at is the height of a model rocket is launched into the air and is modeled by the equation h equals negative 16t squared plus 64t, where h is the height of the rocket in meters and t is time in seconds. So part A, how long will the rocket stay in the air? Part B, what is the maximum height of the rocket? And C, when will the rocket reach its maximum height? So we're going to start by looking at A, how long will the rocket stay in the air? So we're basically trying to figure out, well, when will it hit the ground, essentially, which means we're looking for the zeros. So we need to factor. So if we have h equals negative 16t squared plus 64t, we need to look for a GCF. So the GCF that we're going to factor out is negative 16t. So let's go ahead and do that, please. So when we factor out negative 16t, inside the brackets we're left with t subtract 4. So now what we can do is set each of those factors equal to 0 and solve for t. So we have t is equal to 0 and t is equal to 4. So that means if we were to draw ourselves a little sketch here, we would have 0 and 4. So the parabola is going to open upside down because we have a negative 16t. So it's going to hit the ground at 4 seconds. So that means it's in the air for 4 seconds. So therefore the rocket is in the air for 4 seconds. Let's take a look at part B. What is the maximum height of the rocket? So whenever you see maximum or minimum, that is our clue that we're looking for the vertex. So what we're going to do here is we're going to use our two zeros. We're going to find the axis of symmetry, which gives us the x value of the vertex. And then we're going to be able to plug in that x value of the vertex to find the y value of the vertex, which is our maximum height. So essentially what we're looking for here is the y value of the vertex. So I know my zeros are 0 and 4. So if I add them together and divide by 2, my axis of symmetry is 2, because 4 divided by 2 is 2. So then what we're going to do is we're going to plug in x equals 2 into the equation that we're given. I guess instead of x here, I could use t for time. So t is equal to 2. So h is equal to negative 16 times 2 squared plus 64 times 2. So h is equal to negative 16 times 4 plus 128. H is equal to negative 64 plus 128. So h is equal to 64 meters. So we can make our conclusion. So therefore, the maximum height of the rocket is 64 meters. Okay, let's take a look at part C. So part C is when will the rocket reach its maximum height? So this essentially is the x value of the vertex, which we actually already calculated in part B. So that's the AOS. So if you recall, that was t is equal to 0 plus 4 divided by 2. So t is equal to 4 divided by 2. T is equal to 2 seconds. So therefore, the rocket will reach its maximum height at 2 seconds. Okay, let's go ahead and look at the next question. Question number 2. A cliff diver jumped off of a cliff into the ocean while vacationing. His height as a function of time could be modeled by the equation h is equal to negative 16t squared plus 16t plus 480, where t is time in seconds and h is the height in feet. So part A says, how long did it take the diver to reach the maximum height? B, what is the highest point the diver reached? And C, after how many seconds did the diver hit the water? So let's just take a quick look at these questions here. So maximum height, so for A, that means I'm looking for the vertex. B, what is the highest point the diver reached? So again, that's the vertex. And C, after how many seconds will the diver hit the water? So that's our zeros. So I'm actually going to start with part C when I'm solving this because I'm going to use the zeros to help me figure out the vertex anyway. So let's go ahead and do part C first. So in order to find the zeros, we're going to have to factor. So first thing I'm going to do is I'm going to look for a GCF for all three terms. So I have negative 16t squared plus 16t plus 480. So I'm going to take out a GCF of negative 16. And when I divide each term by negative 16, we're left with t squared, subtract t, subtract 30. Okay, so now we need to find two numbers that add to give us negative 1, which is the middle term, and multiply to give us negative 30. So I know one of my brackets has to be negative, the other has to be positive. So I'm going to use 6 and 5. That will add to give me negative 1, which is my middle term, and when I multiply negative 6 by positive 5, I get negative 30. So those are my factors. So then we're going to set each of those factors equal to 0 and solve for t. So we have t is equal to 6 and negative 5 is equal to t. But because time cannot go backwards, the t equals negative 5 seconds is what's called inadmissible. So time can't go backwards, so we can just kind of cancel out or ignore the negative 5. So that is not going to work. So our answer has to be t is equal to 6 seconds. If we were to draw ourselves a little sketch to kind of model the situation here, so I would have one zero at negative 5, the other one at positive 6, and I know my parabola opens downward. So up here is where the diver is at the y-intercept. So we don't really count what's behind there because that's back in time, which is inadmissible. Okay, so essentially I'm going to just cross that out. So before I go to part A, actually I'm going to make my conclusion. So therefore, the diver hit the water in 6 seconds. Okay, back to A. So to find the maximum height of the diver, we're going to use our axis of symmetry. So t instead of x this time is negative 5 plus 6 divided by 2. So t is equal to 1/2 or 0.5, and that's seconds. So how long did it take the diver to reach the maximum height? Half of a second. Okay, let's move on to part B. What is the highest point the diver reached? So we're going to take that t is equal to 0.5 and we're going to substitute it into the original equation. You could either leave it as a fraction or change it to a decimal, whatever you prefer. So when I sub in 0.5 squared, so negative 16, so 0.5 squared is a quarter, or 0.25, plus 16 times a half is 8, plus 480. So h is equal to negative 16 times a quarter is 4, negative 4, plus 8, plus 480. And simplifying here, we get h is equal to 4 plus 480. So h is equal to 484. So the height is equal to 484 feet. So let's go ahead and make our conclusion. So therefore, the highest point the diver reached is 484 feet. Okay, that's it for today. Thank you for your attention. Bye-bye.